Okay, so the first section of chapter 9, 9.1, is polynomials. Okay, so the first thing we're going to start off with is a definition. So the first one is monomial. A monomial, which mono means like singular, so a singular form of a polynomial, is either a number, a variable, or a product of numbers and variables that have only positive exponents. Okay, so we've got some examples of things that would be not monomials and things that would not be monomials. So things that would be on the monomial side would be like just a regular number, like -4, just a regular variable like y. We could have something like a squared because that would be a product of numbers and variables. It would be a product of variables because a squared is the same as a times a. So that would be fine. Here we can also have a number out front like 1/2. Then we can have x to the power of 2 and then y because that's all a product of numbers and variables. Okay. Now things that would not be monomials are over here. Okay, so the reason each of these is not a monomial is because it doesn't fit one of those things. So it's not a number, variable, or product of numbers and variables. So first thing there, 2 to the power of x, well the thing that's wrong with this one is that power of x. Okay, because we can't have the power of a variable, we can only have to the power of a number. So that would be not good, making it not a monomial. The next one here, what makes it not a monomial is the plus sign in between. Okay, so we can have product of numbers, so we can have numbers multiplied, but we can't have that plus sign in between. That actually means something different. This would actually be a binomial because it would be two terms, which we'll talk a little bit more about later. Next one here, we got 5a to the power of -2. This one's not a monomial because of that negative power, so that's not good there. And then the last one, 3 over x, so we can't divide by a variable, so that's what makes that one not a monomial. Okay, so now what we're going to do is we are going to look at some things and figure out if they're monomials or not. If they are, we put yes and say why. If it's no, we put no and say why. Okay, so for a, we've got a squared, b to the third, and c. Okay, so with this one, we're looking for numbers, variables, products of numbers and variables. Well, this one all looks to be products of variables here, right? Because a squared is just a times a, b to the third, b times b times b, and then times c. So that would just be a product of numbers and variables or a product of variables. So this would be yes. And for our explanation, we could put product of variables. And it's all positive exponents. That's an important piece of that too. Okay, so the next one there, we've got 1 over x. Okay, so looking back up to our examples of things that were not monomials, we decided here that we couldn't divide by a variable there because we can't have negative exponents. We can only have positive exponents. So we remember if something's on the bottom of a fraction and it's a variable, that means it has a negative exponent. So here, this one would be no. And then you could put, we can't divide by a variable, or what's wrong with it is dividing by a variable. Okay, we can't have that. Okay, so if you guys look at on page 382, A through D, try those out and then I'll tell you what they are. So A, they got yes because it's just a number, so that's fine. B, they got no because it's got a negative exponent. C, they got no because we're dividing by the variable just like we were on that last one there. And then D, they got yes because that's a product of variables. Okay? Okay, so the next thing here is polynomials. So polynomials, poly means like many, so it's many monomials put together. So monomial or sum of one or more monomials. Okay, so an example of this would be x to the third plus x squared plus 3x plus 2. So we're basically taking a bunch of monomials or singular ones, putting plus signs in between them, and that makes them a polynomial because there's multiple of them. So each monomial is considered a term. So we'd have 4 different terms there, x to the third, x squared, 3x, and 2. Okay, so each of those is a term in that polynomial. We can also have subtraction with these because subtraction is the same thing as adding the opposite. So like if we had like 3x minus 5 or something like that, that would be still considered a polynomial even though it has subtract there, because this is the same as adding a -5. Okay? So then with our polynomials, we've got basically 3 specific types. So we've got the monomials, which we talked about, which would just be singular. Then we've got a binomial, which is 2 terms, and then trinomial is 3 terms. So like binomial, like bicycle, has 2 wheels. Trinomial, like tricycle, has 3 wheels. So binomial means 2, trinomial means 3. Okay, so then we've got some examples here of binomials and trinomials. So binomials are 2 terms put together. So like x plus 2 would be a binomial. 5c minus 4, so basically being split by that subtraction sign there, and then 4w squared minus w, those are all binomials because you've got 2 terms split by either a subtraction sign or an addition sign. Then with our trinomials, basically we have 3 things being split by those addition or subtraction signs. So we've got our different terms there, all being split by either a plus sign or a minus sign. Okay. Next page here. Okay, so for example 2, we're supposed to figure out whether each expression is a polynomial, and then if it is, we're supposed to identify it as a monomial, binomial, or trinomial. Okay, so the first thing we're looking for is to see if it breaks any of those rules. So see if it's got like a negative exponent, or if we're dividing by a variable, or something that makes these goofy. So that's the first thing we're looking for. Then if we decide there's nothing goofy, then we got to figure out if it's a monomial, so 1, binomial 2, or trinomial 3. Okay, so if we're looking at that first one there, we got negative 4x plus 2. So I don't really see anything goofy with that because it's all product of variables and numbers, so that's good. We do have a plus sign in there, but all that means in this case is that it's splitting up 2 different terms. So since we have 2 terms here, this would be yes, it's a polynomial, and specifically, it's a binomial because there's 2 terms there. Okay. Now b is a little bit tricky here because we've got 5 plus 3x squared plus x plus 2. Okay, so this one, when we're looking, we've actually got 4 different terms, but there's not an option with 4 terms. So you got monomial, binomial, trinomial. We don't have like a quadnomial where there's 4. We only have those 3. So what we have to consider here is there anything we can combine? Well, if we look, 5 and 2 are things we can actually add together, right? So if we kind of simplify this out a little bit, 5 and 2 make 7, plus 3x squared plus x. So that kind of simplified it down a little bit. So now when we're looking at this here, does it fit all our rules? So we got just regular numbers and variables being multiplied, being split up by those plus signs. So all of those things are good. So I would say yes, it's a polynomial. And specifically, since there's 1, 2, 3 terms, it would be a trinomial. So always watch to see if there's anything you can combine before you give it a specific name. Okay, and then the last one here, we got 3x to the power of negative 2 plus 4x to the third. So again, we're looking for anything goofy here. Well, I do see something goofy with this one because we've got the power of a negative, right? So we know power of a negative means that would flip to the bottom. So that's the same as x to the power of 2 on the bottom. So we know either way we write that, whether the variable's on the bottom of that, dividing by a variable, or a power of the negative, that one would be no, that it's not a polynomial. Okay, so sometimes you have no for those. Okay, so on 383, try out E through G, and then we'll talk about them. So for E, they got yes, and they got binomial, so 2. F, they got no, because it's a power of a negative there. And then for G, they got yes, and they got trinomial because there's 3 different terms. Okay, the next thing here is arranging polynomials by their powers. Okay, so what they're going to do is they're going to give you a polynomial here, just written in a random order, and they're either going to ask you to do it in the ascending order or the descending order. And then they're going to either ask in terms of x or in terms of y. Okay, so descending is going down. So descending we are starting with the biggest. So you start with your biggest power and you work your way down. Where ascending, and I always think of planes with these, so a plane is descending when it's going down, a plane is ascending when it's going up. So for ascending, we are starting with the smallest. So we start small and work our way up to big for ascending. So descending going down, ascending going up. Okay, so the first things here are just written in a random order. Then what we're going to do is we're going to arrange these by their powers. So when we're doing descending, we want to start with the biggest. So our biggest power here would be 2 for the x, so we're going to start with 2. Then our next biggest power would just be x by itself, which would be 1, so that goes next. And then our last one would be 1 by itself because there's not a variable with it. Okay? Now, ascending is basically the opposite of that. We're starting with our smallest power, which would be the 1 because there's no x with it, then the 2x because that would be x to the power of 1, and then x squared would be the biggest power there. Okay, so now this gets a little bit tricky when we have multiple variables. So if they're asking you to arrange it in either descending or ascending, they'll tell you in terms of one of the variables. So this first one here is in terms of x. So we could care less what the y's are, we only care about the x. So when we order this here, we're looking for our biggest x value, which in this case would be x squared. So we're going to lead with x squared. And then our next one, since we're still caring only about the x's, our next biggest one with x is 3xy. So that would be x to the first, so that's going to go next. And then the last one there is y squared because that doesn't have any x's. So even though it's a power of 2, that's the y, and in this case we're not caring about the y, so that one goes last. Now if we're going the other way with this, we start with the lowest amount of x's. Well, there's no x's in y squared, so we start with that because there's none. Then the next one has 1x, and then the biggest one is x squared because that would be 2 x's. Okay? Then if we're arranging something in terms of y, we're basically doing the opposite of what we just did. So you're starting with for descending, starting with the biggest y, which would be y squared. Then you've got 2xy, so you're going to go the 2xy next because the y is to the power of 1. And then x squared doesn't have any y's, so that one goes last on descending. And then ascending is basically flipped around. Okay, so just making sure that you're doing those in the right order there, and making sure you're doing it in terms of the right variable. So just pay attention to that stuff. Next thing we've got here is degree of a monomial. So the degree of a monomial is the sum of the exponents of the variables. Okay, so we've got a monomial here, like we've got negative 3x squared. So what we do is we add together all of the exponents, and that's our degree. So here, only exponent would be x to the power of 2, so our degree is 2. For the next one, we've got 5pq. Well, we've got two variables there, so the p, since it's just by itself, is to the power of 1. The q is to the power of 2, so we would add the 1 and the 2 together, so our degree of that monomial would be 3. And then if it's just a 2 by itself with no variable there, that's going to have a degree of 0, because if we think about it, not having a variable there would be like x to the power of 0, which is 1. So that degree would be 0 if there's no variable. Okay, the next thing here is degree of a polynomial. So basically we're going to use what we just did with the monomials to figure out the polynomials. So it says find the degree of each term, which would be the monomials, and then the greatest degree is the degree of the whole thing. Okay, so here we've got some examples. We've got the polynomial, or a binomial in this case, 2n plus 7. So our two different terms here would be 2n and 7. So the degree of 2n would be 1 because n is just to the power of 1. And then since there's not an n with the 7, that has a degree of 0. And then for our degree of the whole thing, we pick the biggest one, which in this case would be the 1. So that's the degree of our polynomial. Same thing with the next one. So we've got 3x squared plus 5x. So our two terms there would be 3x squared and 5x. So when we're figuring out the degrees, x is to the power of 2 here, so that's a degree of 2. X is to the power of 1 there, so that's a 1. So the biggest of those two would be the 2, so that's our degree of the whole thing. Same thing happens here. We break it into our terms, so we got to the power of 6, so degree of 6, power of 3, degree of 3, just a 1 by itself, degree of 0, so our biggest one there is the 6. And then the last one here is kind of a tricky one, but if we break it into its different terms, we've got 5x to the 4th, negative 4a squared, and b to the 6th, so that all goes as 1 because we split up the terms in between our subtractions and additions, or additions and additions, or whatever the mix is, but that separates our terms, so this all goes together as 1. Okay, so this one would be negative 4a squared, b to the 6th, and then 3x. So when we're looking at the degrees here, the first one you got x to the 4th, that's just 4. Here you're going to have to combine, just like we did on the other page, we're going to have to take those powers and add them together. So we've got 2 and 6, so the total degree for that one there is actually 8. Okay, so be careful on ones like those where you have to actually add the powers together. And then for the last one there, x to the 3rd, or not x to the 3rd, 3x, the x is just to the power of 1, so degree of 1, so the biggest out of those is 8, so our whole degree there is 8. Okay, so let's do some examples that are like these. So we're supposed to find the degree of each polynomial. Okay, so what I usually do is I break it into my terms. So my two terms here would be 8b to the 4th and 9 squared. Okay, so truthfully here, if I take 9 and square it, that's not the same as like having a variable squared, because I can actually take 9 and square it and come out with something simplified. So 9 squared is actually 81, so I'm actually going to replace the 9 squared with an 81. So if you've got anything you can simplify, you want to kind of start with that. So really here our terms are 8b to the 4th and 81. So then I figure out my degrees. Oops, did I spell degrees right? Nope. Degrees. And then, so when I'm looking at this first one here, I've got a power of 4 there for the b, so my degree of the first term would be 4. Here, it's not to the power of 2 because that only works for variables, so actually our number is just 81, so this has a degree of 0. So then our degree of the whole polynomial is the biggest one there, so it would be 4. Okay. Next one here, we're going to do the same thing, so we're going to break it into our terms. So our different terms here would be 2ab, 3a squared, b, plus 5a to the 4th, b squared. Then I figure out my degrees for each of those. So 2ab, my a would be to the power of 1, my b is to the power of 1, so those combined together would give me a degree of 2. My a to the second, b to the first, so 2 plus 1 would give me a degree of 3 for the second one. And then the last one, a to the 4th, b to the second, 4 plus 2 is 6. So the last one has a degree of 6. So then my degree of the whole polynomial is the biggest one, which would be 6. Okay, so I'm going to have you guys try on page 384, h through I. So for h, they got a degree of 2, because that would be the biggest one. And then for I, they got a degree of 4. Okay, so 2 and 4 for those. Okay, and then our last example here is going to be example 8 on page 384. So we'll look at that one. So it's at the very bottom of the page. So it says the expression 14x to the 3rd minus 17x squared minus 16x plus 34 can be used to estimate the number of eggs that a certain female moth can produce. In the expression, x represents the width of the abdomen in millimeters. About how many eggs would you expect this type of moth to produce if her abdomen measures 3 millimeters? Okay, so the first thing we've got there is we've got an expression, which is 14x to the 3rd minus 17x squared minus 16x plus 34. Okay, now what they tell us is that x represents the width of the abdomen in millimeters. And we know we've got an abdomen that's 3 millimeters. So basically we know our x is equal to 3. So what we're going to need to do here is plug that 3 in for the x and then solve this out. So we'll have 14 times 3 to the third minus 17 times 3 squared minus 16 times 3 plus 34. Then we just work our way down and kind of simplify each of these out. So the first thing I would probably do here is take care of my to the third and squared. So if I take 3 to the third, that's 27. So I'll have 14 times 27 minus, and then 17 times 3 squared is 9, minus 16 times 3 plus 34. Then the next thing I would probably do is go through and figure out all of my multiplications here. So I'd do 14 times 27, which, let me grab my calculator. 14 times 27 is 378 minus 17 times 9, which is 153, minus 16 times 3 is 40, oops, the wrong thing there. 16 times 3, 48, plus 34. Then I'm just going to go and I'm going to subtract all those and then add the last one there. So if I do 378 plus, or not, shoot, scratch that, 378 minus 153 minus 48 and then plus 34. So I just plug that in my calculator there. I get 211. So 211 would be my total there. So I just had to plug in what they told me the variable was and then solve it out just using order of operations. Okay, so that's all we've got for notes. So your book page is 386, 16 to 56 even.